Hello everyone. So far I remember in our class we have completed DES, Data Encryption Standard. So in our today's class I'm going to discuss on block cipher operations. The slides I'm going to use in today's class have been taken from Prof. Raj. We have already discussed DES in our class. At the end of the class, I already mentioned that DES is not considered secure anymore because although it utilizes 64-bit keys, but actually 56-bit key they are using, because remember when we generate the key we have seen that from 64-bit after permutation it has been reduced to 56 bits. So to make DES secure, several other technique has been proposed. One is called double DES. As the name suggests, double DES, that means the operation of DES would be performed 2 times. Then another one is triple DES, then DESX. All these things I am going to discuss in today's class. The next one is encryption modes for long messages. Usually, as we have seen that in case of DES, the block size is only 64 bits, whereas the messages which we exchange between the users could be more than 64 bits. It could be a long message. In those cases, how we can perform the encryption and decryption operation? We have couple of modes already proposed. One of them is electronic codebook, in short we call it ECB. Another one is cipher blockchaining, then cipher feedback, then output feedback, then counter mode. These modes are really important for you to understand because your project would be related with these modes. You have to implement these modes with DES encryption. The idea behind proposing double DES is that since DES only has 56-bit key, if we encrypt any plain text 2 times using DES with 2 different keys, it will increase the security. So that's why this is called double DES. Now, how actually we can do that? Let's take a look. So let's consider that we have a plain text. That plain text will be passed through DES encryption algorithm, and from the encryption algorithm it will generate intermediate cipher text called X, and in this case we are going to use key 1. Again this X will be passed through DES encryption utilizing another key which will produce the cipher text. This is the idea behind double DES. Now how this thing is happening? If we would like to get the cipher text, we have to encrypt the plain text with key 1. We are going to perform the encryption with key 1. Then this one is our X. And then this X will be again encrypted with key 2. Then we'll get our cipher text. Okay. Now In case of decryption, how the decryption happen? Ciphertext is passed through the DS decryption algorithm. Please keep it in mind then, since the last key was K2 in case of encryption, in case of decryption we are going to utilize K2 first. If we utilize K2 only, then we are going to get X, and then we are going to perform decryption again with K1. It will produce the plain text. If we have to write an equation for that, so how we can write it? Plain text, we passed the ciphertext, we passed K2 in a decryption algorithm. This one is going to produce X, and this one, if we pass this one, if we pass through another decryption algorithm with K1, sorry, it must be 1, K1, we'll get the plain text. These are the two relevant equations we can get. One for how we can get the ciphertext, another one how we can get the plain text. This is what we were discussing. Let's take an example that our plain text is 5 bits, so it will produce 5 bits ciphertext. Our keys are of 3 bits each. Okay, so in this case, if we consider a brute force attack, then the combinations we have to try here is that 2 raised to the power 6 in this example, since our keys are of 3 bits each. So similarly, in case of DES, since the key of DES is 56 bit, so if we apply any brute force attack, it needs 2 raised to the power 112 combinations to try to find out the plain text from the ciphertext. However, in reality, we have one attack in this kind of cryptographic technique. That one is called meet in the middle attack. What is this meet in the middle attack? I'm going to discuss in details, but before that, let's discuss a little bit about the developers. This attack was developed by Diffie and Hellman. They are renowned cryptographic scientists, or I would say they are renowned researchers on cryptography. They propose a couple of algorithms which we'll discuss in our coming days. In case of meet in the middle attack, we consider that we have the plain text, we have the ciphertext. We don't know the keys. Remember what I mentioned before in the class is that in case of cryptanalysis, we try to find out the plain text from ciphertext without knowing the keys, or vice versa. In this case, this X plays an important role in meet in the middle attack. How is that? Let's take a look. Let's say in meet in the middle attack, we know the plain text, we know the ciphertext, but we don't know the key or keys. We have to find out the keys. How we can find it out? Let's consider that we have the plain text, we are going to use a random key, or if we apply brute force attack, we are going to try a combination of keys. We are going to perform the encryption operation. It will produce X. Now, again, the value of X, all the values we receive for different random values, we are going to save it somewhere. We can save it in a file, we can save it in any data structure. Now, we'll perform the decryption operation. As I said, we already know the ciphertext. We'll perform the decryption operation with random keys. Every time after the decryption, we are going to check, let's say this is X bar. We are going to check whether the X is equivalent to X bar or not. If both of them are same, it means that R1 is our key 1. It means that R2 is our key 2. Look, without knowing the keys from the plain text and ciphertext, we can get the keys. So this one is called meet in the middle attack, and because of that, the strength of D is not anymore 2 raised to the power 112, which can be considered as 2 raised to the power 57 operations, and which is only twice as secure as single DES. Is not that secure.